What's going on, guys? Mr. Scott here, another video lesson for you. I wanted to cover simplifying expressions today. We're going to be looking at section 8.4 and 8.5 in your book, okay? What we're doing in this unit is we're dealing with rational expressions, okay? Rational means fraction, so we're dealing with fractions. Nobody likes fractions. But in 8.4, we're talking about multiplying and dividing fractions. We're going to do a quick example of multiplying fractions together and kind of talking about the process to which you need to go through to simplify two expressions after you've multiplied them together, okay? So, I have two rules of thumb. First rule of thumb is to factor. Before you do anything else in these problems, it's important that you factor everything out completely, okay? Then, once you've factored things out, what happens is you can actually cancel stuff out, okay? So, go back to Algebra 1 in your mind and think about multiplying fractions together, okay? If I had something like 1/2 times 2/3, any fractions, all you do is multiply straight across the top and the bottom, okay? 1 times 2 is 2, 2 times 3 is 6, and then we can actually simplify this further and you get 1/3, okay? So remember that, we're multiplying straight across the top and straight across the bottom. All right. But before we do that, you have to factor the expressions completely. We have two expressions, one here and one there. Let's split everything up as best as we can, factor everything as completely as we can, and then we'll see if stuff cancels. All right, this numerator, x plus 5, doesn't factor any farther, so we'll leave it alone. Right here, though, the denominator of this guy, that actually has a 4 in common between these two terms. So you can divide out a 4. You can factor out a 4. So put a 4 in front. You have some parentheses, and we're going to write what we're left with. So if you divide a 4 out of this, you're left with just x. If you divide a 4 out of the negative 16, you have a negative 4. 4 divided by 16 is 4. Okay. We don't have to do anything else yet. We still have to factor. This guy, similarly, what I see right away is that we have a greatest common factor of 2 between those two terms. It's going to go farther than that, but let's not do too much at once. Let's just pull out that 2 and write what we're left with. Dividing that by 2, x squared is left, negative 32 divided by 2, negative 16, okay? And again, that's going to go farther, but let's just do a little bit at a time. All right. Now let's factor this, okay? In my Algebra 1 classes, these kind of expressions, I always try to remind them x squared plus, it's almost like there's an invisible 0x in the middle. And if you remember that, so we're trying to factor this. If you remember that there's almost a 0x in the middle, what you're doing is you're looking for two numbers that multiply together to get negative 25, but then when you add them together or combine them, you get 0. Okay, so that's just kind of a little trick. And what it is, negative 5 and positive 5 satisfies that. So negative 5 times positive 5 is negative 25. But then when you combine them, add them together, you get 0. Okay? So those are our two magic numbers. This factors into x plus 5 times x minus 5. Okay? All right. It's almost factored out completely. This can go one step farther, so let's do that. I'll write everything as it is. Okay. This factors very similarly to how this one did, okay? But instead of a positive 5 and a negative 5, which gave you this negative 25, right? You've got a negative 16 here. So your two numbers that multiply together to get negative 16, but then when you add them together, you get 0. That's positive 4 and negative 4. So this factors into x plus 4, x minus 4. All right, write this here. All right, now, completely factored. There's nothing else we can do. So now all we got to do is multiply these two expressions straight across the top and straight across the bottom, and then see if anything cancels, okay? Remember, with multiplication, it doesn't matter what order you put stuff in, right? Because, say, for example, 2 times 3 is the same thing as 3 times 2, okay? It doesn't matter what order you put them in. So when we multiply these out, we can reorder them however we like. So I like constants, numbers, to be out front. Okay, so when we multiply these together, you're basically doing x plus 5 times those things right there, these three terms, 1, 2, 3. Okay, so we're just going to write them all next to each other. 2 in front, I like the constants out front, and then we write these three binomials, x plus 5, doesn't matter what order, x plus 4, and x minus 4. That is the entire numerator of that expression, okay? We multiplied these together, and we got that. Now we're going to do the same thing here. Multiply straight across the top, or the bottom, and we're going to write the constant out front, okay? And we're going to write these three binomials just right next to each other. Okay, so just to recap. We factored, which took quite a few steps. We multiplied the two fractions together, the two rational expressions together, and now we have one big rational expression that is completely factored out that you can cancel things out of. If you have the same term on the top and on the bottom of a fraction, it can cancel. So each individual piece here is a term. So right here, if you notice, you have an x plus 5 on top and 1 on the bottom. Those can cancel. You have an x minus 4 on the bottom. You also have 1 on the top. So those can cancel as well. 2 divided by 4, that's going to simplify a little further. But I think we've got it. All the pieces that can cancel so far are canceled. So let's write what we have left. We have 2. The only thing that's left up top is an x plus 4. Okay? Now on the bottom, we have a 4. And all that's left there is an x minus 5. So that's almost it. But if you look at it, you have a 2 on top and a 4 on the bottom, and that can simplify a little bit farther. Okay? If you take a 2 out of each of those, 2 divided by 4 is really just 1 divided by 2. 2 over 4 is the same thing as 1 over 2, right? So this 2 goes away. X plus 4 is now all by itself, because that's really a 1 now. And then divided by, when we took a 2 out of this 4, you're left with a 2. And the x minus 5 is left chilling. So that right there is as simple as that can get. That expression is completely factored and completely simplified, and that's your final answer.